Welcome to the Thinkific course on AWS Redshift. During this course, we will be covering the various data storage services that exist on AWS as well as their benefits. We will also be finishing by covering up Redshift-specific features. Before we talk about the options available to use in AWS, let's briefly review the benefits of using cloud technologies. Traditionally, we would need to run our code on hardware that we've purchased inside data centers that we've built up. As you can imagine, this is both expensive and time-intensive. We can utilize AWS servers that already service customers globally. We would also only need to pay for computational power when we need it, and this provides easier scaling as we can request more server space on demand. Additionally, we don't need to invest in our own data servers and infrastructure in order to expand our operations globally. One of the most popular services that Amazon provides is known as S3. S3 is similar to Google Drive in that it is a cloud-based file storage system where teams can store and share files. Files are grouped together into buckets, which are similar to folders except for the fact that they require all files inside to match certain criteria. Finally, we can query our data inside S3 buckets as if they were a database using Athena. While lacking a lot of the nicer features of a real database, Athena will still allow us to quickly query and join large files together without having to pay for an entire database. When we talk about cloud computing, there are several different ways in which these services can be offered. Infrastructure as a service refers to the user renting server space. The user can pick the CPU and RAM requirements and is given full access to the virtual machine. These server instances can be created and managed through EC2. If the user wants a specific SQL Server database, but does not need or know how to manage virtual machines, they would be interested in a platform as a service. The user is allowed to micromanage the permissions and customizations of the database itself, but cannot fully customize the server. Finally, if the user does not need to customize the database, they may prefer to use Redshift. Redshift is Amazon's in-house data warehouse that fully benefits from all the advantages of the cloud. Because EC2 servers are practically like renting a computer, there are a lot of possible tasks that we can use it for. However, most use cases are better handled with other AWS services. For example, we could easily set up an EC2 instance to schedule Python code to be executed, but AWS Lambda allows us to do this without the cost of a server. EC2 could also be used to download a database, but AWS Redshift allows us to jump into working with databases much faster. Finally, we can use a server to set up web applications or dashboards. This makes the most sense as a use case for a server because the website needs to be up with little to no downtime. The main distinction between RDS, or Relational Database Service, and Redshift is that RDS uses the OLTP approach to databases while Redshift uses OLAP. Online transaction processing means that the data is protected from concurrent changes, which allows it to handle real-time transaction data. This is best for when you need data flowing into your database to be readily available for dashboards in real time. Meanwhile, online analytical processing divides data into clusters. This optimizes the database for analytical queries over large datasets, sacrificing immediate access to the data. However, in return, we get much more efficient querying over big data sets. Let's talk a little bit more about how Redshift optimizes its performance over big data. First, the database is separated out into clusters on multiple different servers. This allows for parallel processing when running a query. Memory is also stored so that data from the same column is next to each other rather than each row. This means when aggregating data, the performance is much faster. Aggregations on data tends to be the biggest slowdown when working with data, especially on big data. Finally, Redshift isn't just a relational database, it's a data warehouse. This means that we're able to create dashboards and visualizations directly on top of Redshift. Putting this all together, Redshift is fully optimized for handling and displaying big data.